Hey, we're back in study hall. It's a really quiet study hall, as you can hear, and trying to get some work done, but we got these girls that keep talking. Hey, girls. Okay, I guess they quieted down now. But you put your name on your paper first of all. So we got, put my name here, Hugh Mungus. Okay. And, that's pretty much what they say about me anyway. It's pretty big. I've been lifting a lot lately, so. All right. Graph the 3D point. We're graphing 3D points. We're just kind of getting into these little 3D point stuff. So we're going to do 3x3 systems of equations. Super fun. So the tricky thing with these is that there's 3 axes and they kind of changed around some of the stuff. There's our x-axis. Like normally our x-axis is where the y is, but there's our x-axis. Then our y-axis right there, and then our z-axis like all the way up here. Okay. Now a little trick or a little a tip, a math tip. Math tip 1. The side the label is on is the positive side. So if you're going to go in the positive x direction, that's towards this side right here. If you're going to go in the positive y direction, that's towards this side right here. If you're going to go in the positive z direction, that's towards this side right here. Okay, so we want to graph the point -4, that's x, 3, that's y, 6, that's z. All right, so here's how this is going to go. We're going to go -4 in the x direction. That's going to be back 4. 1, 2, 3, 4. It's back that way. Oh, I just got a text message. All right. And then we got to go 3 in the y direction. That's going to be this way. So now we got to go 3 in the y direction. That's going to be out this way here. 1, 2, 3. Okay. And then I have to go 6 in the z direction. That's kind of like the up. That's the 1, 2, 3, 4, 5, 6. That's where this thing went. So if I was going to like bound there, like boing, 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 it would be like boing, 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 boing. That's like 4 boings that way. And then 3 boings this way. Boing, boing, boing. And then I'm going to elevate up. So that's where I am. We kind of talked about in like 2 dimensions you have like 4 quadrants. You know how in like 2 dimensions you have like 4 quadrants. First quadrant, second quadrant. I said 2. I think I meant to say 4. And then 4th quadrant there. Okay. Well, when you're in 3 dimensions now, we have 3 dimensions. Now this is like a box. It's almost kind of like a box. Here, I'll try to draw. It's kind of like this. Okay. And then in this we have like let's see how crappy I can draw this. Yeah, that's kind of is what, whoop, I think that one got bent a little bit. Oh my God, this is horrible. Try this over here. All right, try to get you to visualize this right way. Okay, so now we have, be quiet, Josh. We have here, let's say, I mean, I know it goes forever, but let's just say we have a cube. And then that cube, let's make it go like, so there's like a divider right down the middle. So it's like the top part and the bottom part. And then you kind of have like in the middle right here, you kind of have an axis that goes straight up and down. Okay, so then that divides it that way. Oh, I don't know if this is even going to work. I've never tried this before. And then it goes like that and like that. So here's like your x, here's like your x and y and z axis in there. Anyhow, what I'm trying to say is there's like a top part to the cube. There's like a front right portion. There's a back right portion. There's a back left portion, so on and so forth. So where this is in the box is this is in like the back, so it's going to the back of the box, and it's in the right portion of the box. So like if there was compartments in this box, it would be like 8 different compartments. It would have a top front right, top front left, top back right, top back left, and then it would have bottom and all those. So 8 different compartments. Okay, so there's your point right there, the 3D point. Okay, the next one we're going to ask you to, and I say graph a line, it's actually not a line. So the cool thing about this is you can just erase stuff when you like screw up. You just like color over it in white, be like graph the, and then just leave that stuff. So graph that stuff. Graph the 3x minus 6y plus 4z equals 24. Okay, we're going to go and talk about intercepts again. So like here, what's the x-intercept? At the x-intercept, you know y equals 0 and z equals 0. So this is going to be the point like something 0, 0. Okay, and then my y-intercept is going to be something, or excuse me, 0, something, 0. And then my z-intercept is going to be 0, 0, something, like that. Okay, so, and then this is like, yay, this is a happy math book problem, right? So what do we have for my x-intercept? Well, if y and z are both 0, then just like cover those things up. Here, watch, I could even just like color them off. Like, oh, y and z are 0. Oh, just like get rid of them. 3x equals 24 when x is 8. Good job. All right, so now there's my x-intercept, 8, 0, 0. Okay, now my green one, my y-intercept, that's going to be negative 4. Because negative 6y equals 24 and y is negative 4. And then my z-intercept going to be 6. Okay, so there we go. Now I got all those three intercepts. Now we got to fit those right on their axes, their respective axes. So 8 on the x and the positive x, that's going to be like 1, 2, 3, 4, 5, 6, 7, 8. It's going to be like all the way over down there somewhere. All right, there's the x-intercept. The y-intercept, that's going to be my green. That's going to be down 4. I'm missing a comma. Down 4 in the y. So that's, actually I said down, but it's not actually down. It's going to be to the left. 1, 2, 3, 4. There we go. There it is right there. Okay, and then my z, that's going to be what? 6. So I go up 6 in the z. 1, 2, 3, 4, 5, 6. Somewhere up there like that. Okay. Now the solution to this is actually, it's not a line. I said it was a line. That was kind of, it must have been on autopilot when I wrote that. So it's a plane. It's a plane that connects those 3 points. So to draw a plane, we just kind of draw a little parallelogram-y looking thing in there so that it looks like, hey, wherever that flat piece of cardboard that goes forever where you can lay down to touch those 3 points, that's going to be the solution to that equation right there. Any point that's in that plane. All right, good job. Now for the the 3x3 system. Take a break. Okay, last part to this, we're going to do a 3x3 system of equations. So I've been telling you all along, make sure you label your equations, number your equations. So I'm going to say that's number 1, that's number 2, that's number 3. All right, so what we need to do, we have 3 variables and 3 equations. We have to eliminate one of the variables. So pick 2 of the equations and eliminate one of the variables. I think we should eliminate, which one did you eliminate? Z first? And that worked out pretty slick, eh? You did Y with 2 and 3. All right, so we'll go 2 and 3 and we'll eliminate Y. All right, so very important that you be neat here and you take your time, because if you make a mistake, it's super frustrating to go back through and try to troubleshoot where that mistake is. Okay, so, and oftentimes the mistake is that you just copied the equation down wrong. So be careful with that. All right, so I kind of double checked that I copied them down right. 2x plus 2y minus z, yep. X minus 2y plus 3, okay. All right, now I want to eliminate y's, which y's are all kind of ready to eliminate right away because they're exact opposites. So these y's are going to cancel out. Okay, they're going to cancel out without even having to multiply by anything. Okay, so add those together now and we'd have 3x plus 2z equals 9. Okay. Well, now what we have there is now we have equation number 4. That's fantastic. Now, we need to do that same exact thing with 2 different equations. So we'll pick like 1 or 2 or 1 and 3 and we'll eliminate y again. So let's see which one looks to be easiest, 1 and 3 or 1 and 2. I guess it really doesn't matter, does it? So let's just pick 1 and 2. Actually, 1 has a 13 in it. But we have to use 1 anyway, so it doesn't matter. So 1 and 3. Okay, so I'll pick 1 and 3 and I'll eliminate y again. So 1 is x plus 3y plus 2z equals 13. And 3 would be x minus 2y. Okay. So now I don't have exact opposites right away, so I'm going to have to multiply each equation by something to get them to eliminate. So I'll multiply the top equation by 2, and I'll multiply the bottom equation by, let's multiply that by 3. Okay, so this is going to be 3x minus 6y plus 9z plus 18. And up here, we're going to get 2x plus 6y plus 4z and 26. And we'll go ahead and eliminate. So here we have 5x, y's are gone, plus 13z equals 44. Alright, hopefully I didn't make any arithmetic mistakes. It only takes one. And now that is equation number 5. Okay. Next step is to take 4 and 5 and solve for x and z. So now I'm going to take 4 and 5 and I'm going to solve for x and z. So take 4 and 5, solve for x and z. Alright. It's a lot quieter now. I had to pause it and move some kids' seats because they weren't, they just wouldn't stop laughing with each other. They just get together and they giggle so much together that it's so distracting. I love that they're having fun and everything, but boy. Alright, 4 and 5. Solve those puppies. Boy, what's the easiest way? We got to eliminate. Probably eliminate x's, huh? Did I make a mistake, Kayla? Do you think I made a mistake? Uh-oh. Let's see. I might have to pause and troubleshoot. Pause and troubleshoot mistake. Alright, we're back. Seem to be okay. Maybe. We'll see. Keep going. Eliminate x. Multiply this by a negative 5. How about? That's going to give me negative 45. Right here is going to give me negative 10z. Right here is going to give me negative 15x. Okay, go down here. Multiply this one by a 3. That's going to give me 15x, 39z, and 120 plus 12 is 132. Okay, x's are gone. The z's end up being 29z equals, and let's see, the difference between those is going to be 87. Okay, so 87 there. So that is going to give a z of 3. Huh. I actually think it worked out there, Kayla. So z ended up being 3. Okay. So, well, I don't know how loud this is going to be on the recording. Z is 3. Take that, put that back in, and find x. So which one's easier? Probably the top one. Put that into the top one right there. So we have 3x plus 2 times 3, which is going to be 6, equals 9. Subtract 6, you're going to get 3. X is 1. Haha. X is 1. I think that's right. Okay, so x is 1. Z is 3. What's y? Take those two, plug those into any one of the original equations for y and or x and z. So I would say, I don't know, the top one would be fine. So for x, I put a 1 in. Okay, it's plus 3y plus z is 3, so 2 times 3 equals 13. Okay, let me clean that up a little bit. 1 plus 3y plus 6 equals 13. Okay, so subtract 7, that's going to be a 6. 3y equals 6 when y is 2. Y is 2. That works. That's kind of a fun little problem because you know what happened there? Hi, Callie. You know what happened there? The answer was 1, 2, 3. Ha! It's as easy as 1, 2, 3. Okay, a lot of work there. Make sure you label your equations. Be neat. Take your time. Have fun. Under 15 minutes. Way to go.